Avondale Shipyards Incorporated, New Orleans, Louisiana, has completed a $42 million expansion and modernization program designed to make it one of the most progressive and competitive shipbuilding in the world. Located on the west bank of the Mississippi River, upstream from New Orleans, America's second largest seaport, Avondale was established at the site of the old Southern Pacific Railway ferry, where railway cars were once transported across the river by barges before completion of the Huey P. Long Bridge. Founded in 1938 as a facility to build and repair barges and other river equipment, Avondale made use of the old ferry ramp and rails to close out. Alternative employees were assembled towboats, fishing boats, sugar mill equipment, and components for locks and dams. Those people are now the nucleus of what has become Louisiana's largest industrial workforce. Today, Avondale, now a subsidiary of the Ogden Corporation, is a bustling, productive, and dynamic organization which constructs vessels of all types for America's merchant marine, the oil exploration and transportation industries, the United States Navy, and Coast Guard. Construction of a merchant vessel, a drill rig, or an oil tanker gets its initial start in the marketing department, where a marketing representative provides liaison with the shipyard's customers. The customer's particular marine requirements are researched and analyzed in detail. These requirements then are reviewed by Avondale's naval architects to ensure that the designs will fulfill the customer's particular needs and requirements. Computers are utilized extensively at Avondale as a design tool. Ship designs stored in the computer are displayed on a large cathode ray tube for study and analysis. Series construction of standardized ships for a single customer or a group of customers is a shipbuilding technique used by Avondale to reduce costs and improve quality. In series production, significant cost advantages are achieved by using the same basic ship design, although many system details can be tailored to meet each customer's requirements. A well-balanced engineering team comprising more than 350 engineers, draftsmen, and supporting personnel develops the naval architect's concept into detailed drawings and specifications which are required for actual construction. Close coordination between the production department and engineering assures the timely delivery of workable systems at lower cost. From engineering, the drawings flow into the mold loft. This information is compiled and loaded into the ship's database. As the work progresses, the ship's file or computer database is enriched with information. This information is used by the parts coder to create the different pieces used within the ship. The parts coder utilizes this data in the form of a program, which is punched on cards and run through the computer. The output from this program is used by the nesting group to produce the final product for use on the numerically controlled burning machines. Nesting consists of placing the scale parts of the ship on a scale-size representation of a steel plate and manipulating the parts until the least amount of overage or drop-off is obtained. This operation is similar to that performed by a seamstress who groups patterns on a bolt of cloth. This information is coded and the final result is transmitted to the burning machine. Along with the burning information, such data as burning time, processing time, and the amount of scrap material produced is used by the production engineer in writing accurate work orders for the yard. A valuable tool in the numerical control process is the cathode ray tube, or CRT display unit. This equipment assures quick and accurate updating of programs written by the coders. Another feature of the CRT units is their ability to check the geometric properties of both parts and nesting programs. Computer programs are checked and rechecked on the cathode ray tube display to be sure that the nesting drawings are correct. The drawing serves as a record of the final nested parts and as a guide for operators in setting up the numerically controlled burning machines to cut the plates. The operator uses a light pen to change the drawings on the display tube. Steel, the primary ingredient of shipbuilding, arrives either by truck, barge, or rail at the yard, where it is unloaded, identified, and placed in the vast steel storage area until required. The 14-acre steel storage area is spanned by two large 15-ton magnetic cranes, which are used for transporting the heavy plates. Programmed plates are lifted from the various storage stacks by the cranes and moved to an input conveyor line for the rotoblast machines. From here, all operations are completely automatic until the plates are moved into the plate shop to await the numerically controlled burning. This automatic operation consists of a collocator which picks up the plates and transports them to the rotoblasting machines for blasting and then automatic surface coating. From here, a collocator transfers the plates to the shop floor to await the automatic burning machines. With its primer coat of paint already applied and dried, the steel plate moves on to the automatic burning and cutting operation. Reference marks are applied to the steel for later addition of structural members. All raw material is handled on and off the burning track by overhead magnetic cranes. Avondale has 4 numerically controlled burning machines, 2 two-axis machines, which are used for square edge burning of shaped ship parts, and 2 three-axis machines, which are capable of beveling plate edges to facilitate welding of joints and fabrication. The 4 burning machines, which can process 1,330 tons of steel in a week, are driven directly from the computer. The numerically controlled burning equipment center punches stiffener locations, waterline frames, and so forth at a rate of 280 inches per minute and burns 1-inch thick steel plates at 18 inches per minute. After the plates are burned, the operator labels the parts with identification numbers to accommodate the use of the steel parts throughout ship construction. Steel plates are loaded onto the panel line by another magnetic crane. Each plate is hydraulically positioned and then tack welded by a semi-automatic welding machine. Plates are added in this manner one at a time up to the size needed for the desired panel. When the ship design requires stiffeners, these are automatically moved into position and tack welded to the plate. An automatic welder simultaneously applies fillet welds to both sides of the stiffener. After the welding process, the stiffened section of the vessel's bulkhead is complete. The panel section then moves to the final station, where it's lifted off the line and transported to the hull assembly area. One of the many new installations at Avondale's main yard is the T-beam shop, a 420-foot-long building which houses the T-beam fabrication unit and related equipment for the preparation of the steel components. One of the most modern T-beam fabricating machines in the United States, this unit is capable of automatically fabricating 60-foot-long T-beams, structural components that are used extensively in the construction of certain vessels. Initially, all surfaces which are to be welded are shot blasted. Then the 2 plates, which will form the T-beam, are fed simultaneously through an automatic welding machine with a double welding head. Behind the automatic welder, the complete beam is automatically pre-shrunk so that it will be perfectly straight after it cools. T-beams as long as 40 feet have been completed in only 15 minutes with this new equipment. One of the 4 oil tankers which Avondale is building for the Standard Oil Company of Ohio dominates this overall view of the hull assembly area. Sub-assemblies and components fabricated in the T-beam shop, on the panel line, and in the machine and pipe shops are positioned and installed or welded in the hull of this vessel, which when completed will measure more than 900 feet long and 173 feet wide. Weighing some 23,000 long tons empty, it will be able to haul 1.2 million barrels, or 50 million gallons of petroleum products across the oceans of the world. Here in Avondale's modern machine shop, fully automated, numerically controlled machinery produces many intricate parts and assemblies essential to ship construction. This vertical boring mill, for example, which is directed by a punched tape, can perform 18 different functions. It selects the appropriate tool for the task at hand and automatically bores or cuts out the part with precision and efficiency. The operator simply places the metal plate on the machine and the punched tape in the control unit then presses the button. Propellers, such as this one, 28 feet in diameter, are bored by a tape-controlled machine. The boring operations, which formerly took 2 or 3 weeks before the installation of this new machinery, is now accomplished in 24 hours or less. The innovative Avondale people also are looking into new, cost-effective ways of making ship propellers. This propeller was cast in the foundry and hand-finished, but Avondale has patented and now is developing a machine which will be capable of cutting and shaping propellers from a solid metal block, or automatically finishing a rough casting. Piping of various diameters, lengths, and shapes to satisfy virtually every shipyard requirement, as well as meet the needs of the petroleum, chemical, and marine industries, are fabricated in Avondale's pipe shop. This 150 by 300-foot facility is equipped to handle any type of pipe fabrication in steel, steel alloys, stainless steel, copper, aluminum, or PVC plastic. The pipes are cut, bent, welded, and assembled to exacting standards, and then stored on pallets outside. From here, they flow in a steady stream to the various job sites. Advanced pre-outfitting techniques are utilized by Avondale to install major subsystems and large pieces of equipment such as this reduction gear assembly or machinery foundations, pumps, valves, and piping as the structural sections of the ship are being put together. Note the openings in this bulkhead, which have been pre-cut to accommodate large pipe sections that have been fabricated in the pipe shop. Among the largest and technically complex vessels ever constructed in an American shipyard are the 3 LNG carriers, which Avondale is building under contracts with the El Paso Natural Gas Company. Each of these ships, which are more than 932 feet long with a beam of 141 feet, will be used to transport 125,000 cubic meters of liquefied natural gas, LNG as they call it, on a large scale from areas which have an abundance of natural gas across the seas to those places which need it, such as from the Middle East to the United States, or from Alaska to the lower 48 states, or even to Japan. Natural gas becomes liquefied and significantly condensed in volume when it is supercooled to a temperature of minus 259 degrees Fahrenheit. At that temperature, it becomes a liquid with 1/600th of the volume of the gas. Thus, much more natural gas can be transported in liquid form in the 5 cryogenic or super cold tanks of the LNG carriers. As an indication of the size of these insulated tanks, Avondale engineers have calculated that it would take an ordinary garden hose running 24 hours a day at least 2.5 years to fill just one of these gigantic tanks. Another statistic of interest, the gas in liquid form carried by one of these 125,000 cubic meter tankers would cover a regulation football field to a depth of more than 100 feet. From the building ways, where the hull was assembled, the huge LNG carrier, now weighing more than 27,000 tons, is moved in stages to the dry dock floating in the Mississippi River. Powerful hydraulic rams are used to shove the hull sideways along the building ways and onto the dry dock. Another new major installation at Avondale is the enormous multi-purpose dry dock which floats in the Mississippi River adjacent to the main yard. The largest one of its type in the world, the Avondale dry dock is more than 900 feet long, longer than 3 football fields, and 260 feet wide. It has a lifting capacity of more than 80,000 tons. and is shown here containing a barge, oil rig, and a tugboat on the same lift. One of the first uses of the dry dock, completed in 1975, was for the installation of a 140-foot-long mid-body refrigerated section to a 669-foot Faro Lines container ship, the Austral Entente. The mid-body section was side-launched into the river and then placed between the bow and stern sections of the Austral Entente in the dry dock. The new floating dry dock has practically eliminated the spectacular side launches of ships into the Mississippi River. During the late 1960s and early 1970s, Avondale delivered a total of 80 ships of all types. Some of them, shown here during launches or undergoing trials, are a high-endurance U.S. Coast Guard cutter, one of 12 built here. Oil tankers. U.S. Navy destroyer Escort, one of 27 built for the Naval Sea Systems Command. Lash cargo ships, 20 of which were built for Prudential Lines, Pacific Far East Lines, and the Delta, Waterman, and Central Gulf Steamship Corporations. Drill ships for offshore oil exploration. And now, the largest of them all, the El Paso LNG carrier, being launched by the new floating dry dock. Avondale began pioneering the construction of drilling rigs and ships for the offshore oil industry in 1948. The rigs built in the early years of offshore exploration were primarily for use in the Gulf of Mexico, off the coasts of Louisiana and Texas. But today, Avondale-built rigs are operating around the world in search of new oil and gas fields. This Sedco semi-submersible drilling rig was partially constructed at the main yard, so tall that a completed drilling platform would be unable to pass under the bridges over the Mississippi. The pontoon and stabilization columns, those sections which extend below the water, and the deck house are then floated downriver to the final assembly site at Belle Chase, a few miles below New Orleans. Here, the deck section is added, and outfitting of the crew living accommodations, drilling machinery, and other systems takes place. Upon completion of this work, the rig moves down the Mississippi and out into the Gulf of Mexico for sea trials. Avondale's accomplishments over the years and its future growth have been made possible by its people. More than 8,000 of them: welders, computer operators, ship fitters, foremen, engineers, draftsmen, and many others whose skills and talents are dedicated to the production of reliable products on schedule, utilizing the most efficient shipbuilding techniques available.